Good morning, all. Up to the last lecture, we have completed up to the interprocess communication. Okay, in this lecture, from the interprocess communication, different scenario about the interprocess communication, how it is actually to be done in the operating system, how it is to be carried out by the operating system. These all the things we have to discuss in today's lecture. Okay, we will start now. In the interprocess communication, we know that the process is in the system is to be a independent or the cooperating processes. Okay, the processes present in the system, it may be of a independent or the cooperating. So what is meant by the independent and what is meant by the cooperating process? When we are saying the process is independent, it means that there is a no communication to complete that process within the another process. The process can stand individually. It is having all the resources and it is having the all the uh, devices, CPUs, resources, those are needed to complete that process, and it can run independently. So that is nothing but the independent process. And what is meant by the cooperating process? The process can be affected by the other processes, are nothing but the cooperating processes, and such cooperating process requires the interprocess communication. Why the interprocess communication is required? To communicate one process with the another process. When it is required, then interprocess communication mechanism is going to be used. Otherwise, if the process is independent, alone it can complete, then there is a no need of a interprocess communication. But there is a very small chance that process needs a the process is a independent only, because we know that the every process is going to fork another process, means every process can call another process for the communication purpose or the different purposes, like a memory assignment and all other things. So the every process is going to be a cooperating one in the your operating system, or simply we can call it as a system. So reason for cooperating process, why we are going to make the process as a cooperating, or why the all the processes are the cooperating? The first one is a information sharing. Okay, in the program also, the program is also a small, when it is going to be run in your memory, it becomes a process. So in the information sharing, we know that there are the different number of variables are present in that program, and that is nothing but the global variables or the static variables. And that static variable or the global variable can be consumed by different functions we have declared into that program. So that is nothing but the information sharing. The shared variables such as the global, static, these are the shared within the different functions. So that we can take these examples as a information sharing. Then computation speed up. Okay, how the computation speed up is going to be happen? Because it is necessary to run the computation activities as fast as possible, and the solution to this is to break processes or the task into sub processes. Okay, why we are making the sub processes? We want to complete the task fastly. So that is nothing but the computational speed up. When we are thinking about only run only one program at a one time, and imagine that program is of a contains the 5000 line of code. Okay, then now you can imagine, when you are taking only example of the only 10-20 lines of a program, then you can say that there is a no need of a cooperating processes. We can simply run only one program independently, because you are having only the 10 lines in your C code. Okay, if you can imagine, if there is the 5000 lines of code, 10,000 line of a code, then simply you can imagine, as an independent process you cannot run this 10,000 line of code at a single go. So there is a need of a breaking that all the program into different parts called as a module. Okay, that is the third point. This is nothing but the we are going to create the module between that program, and we can run it differently, and later we can combine the output. Okay, so that is nothing but the computation speed up and the modularity. And what modularity gives? The modularity gives the convenience. Okay, in what sense it gives the convenience? When we are doing the program into different modules, then that modules we can easily understood, we can easily write, we can easily read, we can easily take the different inputs from that module, we can take the different outputs from that module, and we can use whenever it is needed. So that is the convenience for the cooperating process. So these are the four different reasons. The information sharing is there, computation speed up is there, modularity is there, and the convenience is there for the interprocess, for the cooperating processes. And how we are doing it? By using the interprocess communication. Okay, then what actually means? We know that interprocess communication is nothing but the just communicating between the processes. Then how it is going to be done? It is going to be done by the shared memory and the message passing. Okay, now in detail we have to know that what is meant by the shared memory and what is meant by the message passing. Okay, this is about the this slide, and we will move to the next one. This is the pictorial representation for the message passing and the shared memory. First of all, we will see the shared memory, and then we will go for the message passing. In the shared memory, you can see that this is the shared memory, the memory shared by process A and the process B. So those are the common data are stored into this memory. This is called as a shared memory, and whenever it requires, the process A consumes it, and whenever process B requires, process B consumes it. So this is the simple structured model for the shared memory. Okay, this is your kernel. Okay, the all the things are present into your operating system. The kernel is here, and the process A is here, process B is here, and when they wants to share some data, then that is present into the shared memory. Okay, we can take example now. Your global variable as I is present here, and that global variable is accessed by the function A and the function B. So whenever you are declaring the variable I as a global, then simply it is present into your shared memory, and both the functions can access the data. Okay, here we are assuming that the functions are nothing but the processes, and the process A and process B consumes a shared data present into the, and that I variable present into the shared memory. So this is the shared memory model. What we are going to call it, this is the communication model for the shared memory. Then we will go for the message passing. The messages those are generated are stored it into the queue. Here you can read it. This is the message queue. All the messages that wants to process A wants to send to the B, or the B wants to send to the A, that are stored into the message queue, and where it is going to be stored into the kernel area. In the kernel area, all the messages are stored in the format of queue. Those all the messages that A wants to send to the B and B wants to send to the A. And later, if B wants to send message M0 to A, then simply process B is going to take this one M1, M0 and send it to the process A. And when A wants to send message M0 to B, then it takes from the message queue and sends to the B. Okay, means here you can quite confuse here, just like a message queue also stored in the form of shared memory, but the thing is different here. Here the message queue is maintained in the kernel area, and when the process A wants to send some message to B, means some data to B, then there is a system called like a send is going to be used, and in that what we have to define, to which process I want to send the data. Okay, suppose here process A wants to send the data to B. Okay, then send data to B. Which data? M0 data. Okay, this is the process for the message passing, and how it is received from A, just like a received call, just like a received system call, from where it wants to which process want to receive the data, that is nothing but the A, and which message wants to receive it, that is the M0. So in this message passing we are going to use the system call just like a send and receive. Okay, and in terms of the messages we are going to send the data to that process. Okay, and in the shared memory we are using the share region for process A and process B, and process goes there and access that data whenever it needs. So this is the structure or the communication model for the shared memory and the message passing. We will move to the next slide. So there is again definition given for the independent process and cooperating processes. Independent process uh, cannot be affect or affected by the execution of the another process, whereas cooperating process can affect or affected by the execution process, means it is going to be communicated. And advantages of the process cooperation is nothing but the information sharing, then computation speed up, modularity, then convenience. So these are the four advantages of the process cooperation. Then next one, as a shared memory systems, how it is going to be work now. So if you have any kind of a doubt you can ask, or we will go further. So just I will repeat it into the 2 to 3 minutes. In the interprocess communication, the processes or the independent or the cooperating. If the process is cooperating, then it requires the interprocess communication, and how it is going to be done by using the shared memory or the message passing. Reasons for cooperating processes is nothing but the information sharing, computation speed up, modularity and convenience. We have seen it into detail. These are the communication model, how it is going to be done, message passing and the shared memory. Then what is meant by the independent and cooperating process? These are the advantage for the cooperating processes. Then how it is going to be actually done? The producer consumer problem, it is considered into the shared memory system. Okay, this is the uh, very traditional problem seen into the shared memory systems. There is a one C program is demonstrated for the producer consumer problem. In that we have the two assumption, that buffer that you are having. Okay, in the shared memory you can see this is the shared region. Okay, what this is called as a buffer, this is called as a buffer, and this buffer is of unbounded buffer and bounded buffer. It is having very simple meaning. When we are calling this buffer, this common region has a unbounded, means there is a no size on the limit to store the data, and when we are calling the unbounded, when we are calling the unbounded, then it assumes that there is a fixed buffer. Okay, means when there is an unbounded buffer there is a no limit on the size, when there is a bounded buffer there is a fixed limit of a size is there. Then how we are going to write the data, how we are going to write the C program for the shared memory. Swapnali, can you understood the what is the producer and consumer problem, or what is meant by the at least shared memory? Hello.
Yes, sir.
Okay. What is meant by the shared memory? You are
Yes, sir.
yes, you understood that what is meant by the shared memory, and how we are going to implement that. We are going to take one example of the producer and consumer problem. How we are going to make the shared memory as an example. Okay. In this, we have the two assumptions that your buffer is a bounded and or the buffer is a unbounded. What is meant by the buffer is unbounded? The buffer is unbounded means there is a no size limit on the buffer, and what is meant by the bounded buffer? There is a limit on the buffer. Okay. So in this slide, how we are going to define? So now we are going to write one C program to demonstrate the producer and consumer problem for the shared memory example, where the shared memory is used in the interprocess communication. In the interprocess communication, we are going to use the two things, that is the shared memory and the message passing. How the shared memory is going to be done, we are going to see now by with the help of one C program. In shared memory, what we are going to do, that is the producer and consumer problem. In producer and consumer problem, first of all, we are going to declare the shared data, means we are going to declare the shared region. Then we are going to declare the two function. The first one is a producer and second one is a consumer. Means what the producer is going to do, it is going to generate the data, and what consumer is going to do, it is going to consume the data. So this is the simple problem for the shared region, shared memory. Okay, here the type, depth, struct, and item. Here we are going to declare one user defined structure as a item. Okay, in this item, or simply if you want to make simplification in this program, you can simply without using the structure, you can simply declare here as a int buffer. Okay, to remove the complexity from the program, you can simply define int buffer size. Means here, what is mean by the int buffer? Here now you are going to declare one integer array. What is the size of this buffer? Is nothing but the 10. Okay, and now we are going to declare the two variables, int I and int out. How we are going to use it, we will see. Okay, so this is your shared region. Means what is the shared region now? This buffer area is your shared region, and this buffer is going to be used by the producer and consumer. Okay, how we are going to use it, we will see now. Okay, here the item next produced. Okay, why true? Okay, this condition we are going to use for the in plus 1 modulus buffer size is equal to out. Means why we are going to check this condition? Because if your buffer is full, means your array is already having the 10 items, we are not going to produce more items, because your buffer is a bounded buffer. Means your buffer is having only 10 items into your buffer. So when this condition, why we are going to use, and your array is a circular array, means you are having the in and out as an index point. When your in plus 1 modulus buffer size is equal to out, means your buffer is full. Okay, if it is not full, if it is full, we are not going to do anything. If it is not full, then we can produce next produced item. We are going to place it into the buffer, and we are increasing the in. Okay, in plus 1 modulus buffer size, this is nothing but the increasing the in by plus 1 size. Okay, this is about the producer. And what in the consumer, what we are going to do in the consumer? Okay, yeah, the while true, while in is equal to out, means when your in and out is going to be same, when there is a empty array. Okay, if your array is empty, we are not going to consume anything, because it is simply not having anything in that array, so we are going to do nothing. If it is having something, then buffer dot out from where we are going to take the item from out as a counter, then it is nothing but the next consumed. We can simply display it here by using the printf statement, and we are making the out minus here. So this is the condition for changing the out again. So this is the simple producer and consumer problem, where what it indicates, it is a just an example for the shared memory. Okay, which is your shared memory here? This buffer is your shared memory, and this is going to be used by the producer problem and the consumer problem. So there are the many examples we can take for the shared memory. Again, that is nothing but the when your compiler is going to, this is the another example I am going to tell you, just listen, that when the compiler which produces an assembly code, then assembler consumes it, and assembler may generate object code which is consumed by the loader. Okay, we know that when we are going to compile your program, then first of all it is going to compile it, then it is converted into the assembly language code, then that again we are going to load it from the from your turbo C for to run the program. Means compilation, compile code consumed by the another process, then that assembly code again consumed by the another process. So this is the chain. Means one process is going to do the task, then again process going to take that input, and again, yeah, up to the user will get the output. Then another example for the producer and consumer problem is that when there is a client server model is going to be used. Okay, we assume that producer is a server and consumer is a client. Okay, the practical example is a web server which allows HTML files to run and produces the HTML files and images. These are consumed by the client web browser. Okay, when we are using the internet, we are searching over the Google, we are placing the one keyword on the Google to search, then that keyword is going to the server, then server is going to execute that one and gives the response to you. Means this is again the problem of the producer and the consumer. So this is the example to understand only the producer and consumer, but here in the shared memory we are going to define the shared region, and that is accessed by the producer and the consumer within the bounded buffer. And what is meant by the unbounded buffer? The unbounded buffer is nothing but the when the buffer size is unlimited. Okay, that not happen into the real world. We need to define the buffer size limited. Okay, here you can define 10, 10,000, 1 lakh, 1 lakh, or but here we have to define the some value. So that is nothing but the bounded buffer. When the buffer is not a bounded one, so that is the unbounded buffer. Then about the next slide, that is the an area shared among the process wish to communicate. Okay, that is nothing but the shared memory. And then communication is under the control of user process, not an operating system. The user takes control of the communication. The major issues to provide the mechanism that will allow the user process to synchronize their action when access shared memory. Okay, there must be synchronization required between the processes, uh, and how it is going to be done. Okay, we will see into the next chapter how the synchronization is going to be done between the when the process is going to be communicate. Okay, so this is about the shared memory uh, whole process, how the shared memory is going to be worked, and why the shared memory is required for the interprocess communication. And interprocess communication is done by using the another approach is called as a message passing. And how the message passing is going to be done actually, we are going to we are going to talk it now. Then mechanism for the process to communicate and to synchronize their action. Okay, this is nothing but the process to communicate and synchronize their action. Then message system process communicates with each other without restoring the shared variables. We are not giving to give the shared memory there, and without sharing the variables, without sharing the memory, we are going to communicate. How we are going to communicate? The interprocess communication facility provides two operations, that is nothing but the send message and the receive message. The message is either a fixed or the variable. So you can ask that what is the size of the message. The size of the message is, it is can be a fixed or the variable. With these two operations we are going to send and receive, just we have talked into that diagram. Then if process P and Q wish to communicate, they need to establish a communication link between between them. Okay, when the process P and Q wants to communicate, then there must be a one communication link between them. Then exchange the messages via send or receive. Okay, how we are going to exchange the messages? By using the send and receive. So there are the different implementation issues are there. How the links are going to be established? Okay, here we are thinking about the establishing the link. Then actually how they are going to establish the link? Can link be associated with more than one? If there is a communication between, we are just talking about the communication between two processes. If there are the more number of processes are involved in the communication, then what is the scenario now? Then how many links can be there be between every pair of communication processes? Okay, if there are the only one link is sufficient to communicate, or more than one link is required, then what is the capacity of link? Then is the size of message, that link can accommodate fixed or variable message size? What is the size of the message, that is the fixed or the variable? The link is the unidirectional or the bidirectional? Is link The link is a unidirectional or the bidirectional, that we have to think it about. Then what is meant by the message passing? The implementation of the communication link, that is the physical one or the logical one. Then if it is a physical, then we are going to use the shared memory, hardware bus or the network to communicate. If it is a logical one, then we will see that is the direct or indirect communication, how it is going to be done, synchronization between them, how we are going to do it, and how the buffer is going to be used. Okay, these are all the points we need to cover it. Now if there is a direct communication between the processes, then simply processes must name, we will go one by one. Processes must name each other explicitly. Send P and the message. When process send a message to process P. Okay, when I want to send some message to process P, then send it just like by using the send system call, send message to process P. Okay, when there is a receive message from process Q. Okay, when any process want to receive the message, then it is going to use the receive. And how the receive system call is going to be used? This is the receive Q comma message, that is nothing but the receive message from the process Q. And then what is the properties of the communication link? Links are established automatically. Then links are associated with exactly one pair of communicating processes. Between each pair of uh, there exists exactly one link, only one link is present. Then link may be unidirectional or the bidirectional. Okay, simply it is a unidirectional, means we are going to send only the message and that is received by the another end. There is a no bidirectional communication between the ports. Okay, so this is about the direct communication. We are going to use the send and receive system call for the communication between the processes. Then what is about the indirect communication? Okay, how the indirect communication is going to be take place? The messages are directed and received from mailboxes, also referred as a ports. Okay, so what the thing is going to done here? This is the mailbox. Okay, just like your email id, this is the mailbox. Okay, each mail has a unique id. Okay, process can communicate only if share a mailbox. Suppose there is the process P is there and process Q is there. This is the mail number 1. If process wants to send the mail to Q or the send the message to Q, then that is fetched from here and sent to the Q. And where the Q wants to receive the message from the Q, it is simply use the again access the mailbox and it takes the that mail. So this is nothing but the indirect communication. Means we are not using the send and receive system call directly, but with the help of mailbox we are going to use it. And each mailbox is having the unique ID here, and process can communicate only if there is a sharing of a mailbox is there. How the communication link is established? Link is established only if process share a common mailbox. A link may be associated with many processes. Okay, many processes can access that mailbox. Then each pair of process may share several communication links, and link may be unidirectional or the bidirectional. So this is about the direct communication and indirect communication for the message passing. Okay, here also the send and receive is going to be used by, but it is for the mailbox from the same region or the same mailbox. It is going to be used the uh, these things, these messages are going to be sent and received from the mailbox. The operation on the mailbox which are going to be used, that is nothing but the creation, send, receive the message from the mailbox, and the destroy the mailbox. The many process can share the that mailbox. P1 can send and P2 P3 can receive. Who gets the message? Okay, so these things, many process can share the mailbox in the direct communication is also there. So the two things are remain in the message passing, that is the synchronization and the buffering. We will see it into the next lecture. So for the today's lecture we have seen the, for the interprocess communication there are the two things, that is nothing but the shared memory and the message passing. By using these two one we are going to implement the IPC. Then this is the model used for the message passing and the shared memory. Then these are the types of the process. In the shared memory we are going to use the producer consumer problem. In the producer consumer problem we are going to, for explaining it, we are going to use the one C program that contains the shared memory and the one producer function and the consumer function. In the next lecture you will show me that uh, the C program, and that, yeah, you have implemented the producer and consumer problem. In the message passing we seen that there is a direct communication and indirect communication in the message passing. uh, how the direct communication can be made and how the indirect communication can be made with the help of mailboxes. That 2 points from the message passing is remaining, that is the synchronization and the buffering. We will see it into the next lecture now. If you have any kind of a doubt now, you can ask. If you have any doubt